2.5 goes into solving inequalities. What I have here is an equation, not an inequality. But if I get rid of this equal sign and instead I'm going to put a greater than or a less than symbol, that means that it's going to become an inequality. I know that sounds a little bit weird, but it's actually not too bad. In this tutorial, what I want to do is show you how to solve inequalities visually through graphs. Then in a separate tutorial, I'll show you how to solve inequalities through algebra, which is more of an interval chart. Okay, so why don't we get rid of this and we'll begin. First thing I want to do is show you interval notation again. So we definitely need to be very good at this. -1 all the way to positive infinity. If it has an open circle, that means that it's going to have a round bracket. Positive infinity also has a round bracket because, well, it's not a real number. It's not an actual number. This next interval is from 3 to 9, not including the 3, but including the 9 because it's a closed dot. That means round bracket and then square bracket. This last one has two intervals, which means that right in the middle we should put a U, which means united, okay, or union. So this one is -infinity all the way to -2, including -2. So round bracket because -infinity is not an actual number. And then -2 square bracket because we're including the -2. We don't want to include the 1, but we want to go all the way to infinity, so round brackets for both. If you're solving an inequality algebraically, it could be very similar to this. You still want to make sure that all of your x's and all your other numbers are on one side, but you have a 0 on the other side. That gives you the freedom to then factor these two. Okay, and then what you're going to do is you're going to solve each of the brackets and you get your x-intercepts. So this is essentially what solving an equation is, and inequalities are basically the same thing. But like I said, I wanted to show you visually. So this tutorial is going to be about graphing. Here I have an equation that models a toy rocket that goes up and then back down. Now the question is, over what time interval is the height above 3 meters? So here's a 3-meter height, and I'm just going to label that with some sort of a line. I want to know, well, when is it actually higher than this line? We can already see that this is the point where it's actually higher than the 3 meters. It's not higher right here because that's where it's equal to 3 meters. Okay, so you know what? I should really figure out what those two numbers are and what times those are. So what I want to do is I want to figure out what time it is so that it reaches the 3 meters right here and right here. So what time is it here? I have those two times already, so this one must be the 1.3 seconds. This one must be the 8.7 seconds, but where did those come from? You take your 3 for your height and you put it into the equation, and then you're just going to solve. So what I have here is 3 for the height, and I'm going to bring it to the other side. It's going to become a minus, and that's why I have this -1 here instead of the 2. That's going to become a 0, and now it just becomes a grade 10 question. So I could factor this, or I could do the lazy man's way, which is quadratic formula. Okay, so quadratic formula gives me blah, 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 1.3 and 8.7. So at 1.3 seconds, you're going to have a height of 3 meters. Okay, and then 8.7 seconds is going to give you the exact same thing. Now, I didn't want to know exactly when it's 3 meters. I wanted to know when is it above 3 meters. Well, that's between 1.3 and 8.7 seconds, but not including those numbers because then it would be at exactly 3, not above. So that's why we put these round brackets here. This essentially is how you guys are going to solve inequalities. You just take a look at the graph and see what fits the question. So just a reiteration, what we have before is solving equations. That's where you have an equal sign. But if you're going to be solving for inequalities, you usually have a greater than or a less than sign. Your answer will probably look like an interval, and that's what your solution is. Okay, so here's a little bit more information. You're basically looking for your x-intercepts of the equation. Okay, so here's an example. We have a function and there's 3 brackets. So I'm taking a look and I'm saying, okay, 1, 2, 3, that's a cubic and it looks like a positive cubic. So we should expect it to extend from quadrant 3 all the way to quadrant 1. And because it's like that, I already know that the domain is going to be all real numbers, and it's also going to extend upwards and downwards forever, so all real numbers for your range as well. The zeros, or your x-intercepts, are the opposites of these numbers inside each of the brackets because it's already factored for you. So positive 3 is there, negative 5 is right there, and negative 2. And that's why I knew to put them here, here, and here. Okay, so just to graph it a little bit more accurately, because I know the shape, but I mean, we should maybe figure out where the peaks are. So you might want to figure out where the middle is and then sub it into the equation and get your height for each of your peaks. Okay, now again, that's just an estimation. So the inequalities part, here's the final question. Find out what intervals give you f at x where it's greater than or equal to 0. Okay, so when it's equal to 0, that's these 3 dots. That's when y equals to 0. And notice that I have all these square brackets at those specific numbers. So I want to include negative 5. I want to include negative 2, and I want to include 3. But how did I get these 2 intervals? Well, that's where the greater than part comes in. So it's greater than 0 here, a positive y value, greater than the x-axis, and it's also greater than right here. So those intervals are negative 5 to negative 2, including both numbers, and 3 to infinity, including 3, but round bracket always for the infinity. Here's another example. They gave us a diagram. They want the x-intercept, so we could easily look at the x-intercepts from the graph. Then that's going to help us set up our intervals. So what intervals make it a positive? So positive means positive y values. So right here is above the x-axis, right here, and right here. Okay, kind of autocorrects, but anyways. All right, so this part right here is negative infinity all the way to negative 2, but we don't want to include the negative 2 this time. Notice that it's a round bracket, and that's because at exactly negative 2, our y value is 0. 0 is not a positive number, so we don't include it. United with this little part right here. So again, from positive 1 all the way to 3, but not including 1 or 3 because that's when y value is 0, not positive. So then we get something like this. United with a third one, which is 3 to positive infinity, not including the 3. Okay, so we can't really say from 1 to infinity because again, we can't include that 3 because right at the 3, y is equal to 0, which is not a positive answer. Okay, let's use a different color for the other one. When is it negative? Well, it's negative from negative 2 all the way to an x value of positive 1, but not including those 2 numbers because that's when y equals to 0, which is not a negative number. Well, I haven't actually explained this yet. You always want to put x belongs to because we're talking about the x values. So when we write some sort of an interval, we want to make sure that it's written as x belongs to at the beginning. Okay, the very last example, let's do it a little bit more algebraically. What we're going to do is they haven't factored anything for us, so we want to make sure we factor everything ourselves, bring everything onto one side. Notice that it's an inequality right here. Okay, set it equal to 0 and then start factoring. Okay, so I'm put everything together and I'm noticing, okay, I can take out an x, I factored out an x, and then I could further factor and I'm noticing my x-intercepts are 0, positive 3, and negative 1. If I decide to draw this, it looks like a positive cubic, so I have something like this, and those are my x-intercepts right there. Okay, so where is it less than 0? Less than 0 looks like down here and right here. Okay, so then how do we write this? Because you want it less than 0 and also equal to 0, we're going to have square brackets. So it's going to be negative infinity all the way to negative 1, including negative 1, so square bracket, united with 0 all the way to 3, including both those numbers, square brackets as well. Okay, so this is how you solve inequalities using graphing method.